Okay, orthographic projection is the communication of a 3D object in 2D. So for example, if I was to look at this water bottle, what would it look like from the front, side or top, for example. So to get straight into it, I don't want to waste any time, so I'm going to go through this quite quickly, but you can pause the video if you need to. So here we go. So orthographic projection is the communication, or it's communicating the design of 3D objects by using a series of 2D projected views. For example, if we had a cube, if we looked at it in 2D, if we looked at it from one point, at the front, side or top, we would see a square because a cube is comprised of nothing but square faces. These views, however, are projected onto planes. So these are what are called planes. These are our planes of reference. So we have a vertical plane, which is basically like your wall in your room, and your horizontal plane, which is kind of like your ground. So if we had a 3D object, we project or push what them shapes look like onto them planes, and we'll see what that means now in a minute. These planes are of 0 thickness and of infinite size, but we do see their line of intersection. So we don't have to show the plane boundaries, for example these 3 lines here, but we do show this line of intersection, this XY line, which runs between the 2 of them. Now there is not only 2 planes, there's many planes as we need, but we usually only use 3. We use our vertical plane, our horizontal plane, and then we construct an end vertical plane depending what side of the object we want to look at, which we will look at now. So here we go. Here we have our vertical plane, our horizontal plane, and our end vertical plane. What this means is, one, we're going to project our view this way onto our vertical plane. We're going to see the front of the object. If we project down from top, we will see the plan of the object on the horizontal plane, or the HP. And then if we look from this direction in this way, we're going to see the side of the object, which will be the left hand side of the object over here on this end vertical plane. So the line of intersection between 2 vertical planes is called the XY, or 2 vertical planes, sorry, is called the ZY, which is this line here. And the line of intersection between the HP, or the horizontal plane, and the vertical planes is the XY line. So this here would be XY, and this here would also be the XY line. A plane of reference, so a plane is a flat surface of 0 thickness, they're infinite in size, and the primary planes of reference, which I've already mentioned, are the vertical plane, the horizontal plane, and the end vertical plane. Basically imagine the corner of a room. Now we're going to look at what an object looks like when it's being projected onto these planes. So here we have a simple geometric object comprised of cuboids and cubes, mainly square faces and rectangular faces, which makes it quite easy. If we look, this face here will be the front because it's been projected onto this green vertical plane, which produces our elevation. Now, these projection lines are perpendicular to this face, so all we're going to see is an edge view of all these side faces. So for example, if we look at the different shading here, we're going to see the dark orange faces when we look in here. And we're also going to see the edges of all the objects, or all the side or the faces. If we look down for plan, we're going to see the lightest faces. So we're going to see 2 cubes, or 2 squares and a rectangle, which we see 2 squares and a rectangle. And then if we look this way, in the direction of the XY line, which is shown here, we're going to see these 3 faces. We're going to see a square, and then kind of an L shape that's upside down. We're going to see square, square, and an L shape that's upside down. Now, this is what's called first angle projection, which is the primary method used over here in Ireland. So we're going to focus primarily on this. If we will look at third angle projection in a future video, but for now let's focus on first angle projection. The symbol for first angle projection is here. So imagine this as a conical shape. If we were to stand here looking here, we would see this face, and if we were to stand over here and look this way, we would see this shape. Now, if we were to stand in front of that sketch here, stand here looking this way at our front elevation, without doing anything, without doing what is actually being completed, this is what we would see. We would see the front of the object, we would see the vertical plane here in the background, or it being projected onto it. Now I've shown the outline of it just to make this visually not stimulating, just to make it easy for you to visualize. And then we see the ZY line, which is the line of intersection between 2 vertical planes. So we're going to see the ZY line as the line of intersection, but it is also, if you imagine your door being open to you now, perpendicular, you're going to see an edge view of that plane. So we know that that end vertical plane is there, but it needs to be flat here somehow. And the same here, this horizontal plane, so we can see the XY line, we imagine that that's the ground. We're looking straight in at, and we can't actually see the shape that's being projected, although we know that that's what we see on that horizontal plane. So that shape is there, but we just cannot see it from the view that we're looking in at. So we need to do something. We need to fold this down so that it's in line, so that we do see that shape. So what happens there then, if we look at this next sketch, I'm going to have to rotate the sheets. If we look in this direction here now, we have our vertical plane, and we had where our horizontal plane was. You can see it dotted here. What happens is, we get the horizontal plane, and we hinge it down so that it's in line with our vertical plane. So you can see these lines of rotation. Can't really see the corner here because there wasn't enough room. So we have the hinge line, which is the XY line, the line of intersection, and this rotates down so that it's in line, and then we see this plan. Now, if you notice, these projection lines from our elevation, they come down perpendicular to our XY line and extend on past our XY line and give us where each point is, so which will be shown in the next sketch. Now, some important points to note. So here we go. The elevation and plan are now located directly above or below each other. So if you look at these projection lines here, the dashed lines, you can see that they're directly in line with each other. So for example, that rectangle face there will be on top, this square face will be here, and this square face will be here. And then if we looked at this L shape, that will be looking in here at this edge here, and they're projected straight up. The line of intersection between the two planes acts as a hinge line. The HP, or the horizontal plane, rotates or rebats down so that it's flush with the vertical plane. And then probably the most important point, points in elevation are directly above their equivalent in plan. So if we look at this point here, it's directly above where it is in plan, so we come down and there it is there. Okay, hopefully that makes sense. Moving on to the next sketch, this is what it would look like now on our page. If we looked in, we would see our vertical plane as we did before. We would now see our horizontal plane, and we would see the plan shown. We still cannot see our end vertical plane because it's not rotated out just yet. So what we see the elevation. It shows us our lengths this way and our heights this way. We can see that the points are being projected perpendicular to our XY line, and they come down, and then they show where they are here. Now we have to have these widths in order to be able to find out where these are. I usually put a 20mm gap between the XY and our actual plan. This is just a nice comfortable distance. It gives you lots of room to visualize. The XY line is shown as 1, the line of intersection between the vertical plane and the horizontal plane. It's shown as the edge view of the horizontal plane if it was not rotated down. And then it's shown as the edge view of the vertical plane. If we were looking straight down here, we would see the top of that vertical plane or the top of a wall. Over here we see the end elevation is projected onto the end vertical plane, but that end vertical plane hasn't been rotated out yet. The ZY line shows as the line of intersection between this vertical plane and the end vertical plane, but we cannot see that yet. And it also shown as the edge view of that EVP. The plan, however, shows us the lengths because the object hasn't changed in length. So it shows us lengths and it shows us the widths. And this is also projected over to the end vertical plane. So this YY line shows us the edge of the HP. It shows us the line of intersection between the HP and the EVP. And it also shows as the edge view of the end vertical plane when we're in plan. Hopefully that makes sense. So if you imagine looking back at the 3D image, you would imagine being able to see down on top of this wall, and then the ground would be here. And then if you looked in here, you would see the ground and the wall facing us. Now moving on to the next one, we need to have 3 views, because if we look at this sketch here, we have this object shown here. And we can see what it looks like from the front, and we see this. We see that it looks like from the top, and we see this. However, if we look at from the front of this object, we will also see that. And if we look from the top, we will also see this plan. And same with this object, and this object, and this object, and this object. So what we need to do is we need to construct our end vertical plane, because looking from the side, we can tell that all these objects are different. So to do that, we would have rotated out our end vertical plane, and we would get these side views. Now what happens here is, if we look at this sketch again, so this is showing all 3 planes in their rotations. So we already had our vertical plane and a horizontal plane rotated flush. So the width, or no, ignore that for a second, we have the vertical plane and the horizontal plane that are flush in line with each other, and then we have our vertical plane and our end vertical plane, which are now flushing in line with each other. If we look at this dashed blue line, we can see where the end vertical plane was, and it's now rotating or rebatting again around these green lines until it's in line with this plane here. So now it's all on one flat surface. We can see the different projections being rotated around. So I'll just zoom in a little bit. Hopefully you can see that. And let you pause it there if you need to. We have everything being rotated all the way around so that it's in line. Now if we imagine looking straight down, what we will see is we're going to see a hinge line. So if we look down this ZY line, we're going to see a dot. Imagine it's your door looking down from the top. It's going to swing open. And what that looks like on our sheet is this. So we already had our front view and our plan, front elevation and plan, which are here, front elevation and plan. We then projected over our widths to hit our YY line or our ZY line. Just get that to autofocus. And then we use our hinge point. So if we imagine looking down and imagine this is a door, everything is going to rotate around until it hits this XY line so that it's in line. So we're just going to take these widths, rotate them around. I've shown here the plane in its process of rotation. See these dashed lines? DVP is being rotated around until it's in line with this. And then we just project over our heights, and where they intersect, that gives us what it looks like from the front. I'm going to zoom out a little bit now and talk through the different important points on this page. So the one new thing is, on this end elevation, we're going to see heights and widths. So heights and widths. We see lengths and widths here, and we see lengths and heights in our elevation. We can see our projected elevation, we see our projected plan coming perpendicular to our XY line. We can also see that this comes over perpendicular to our ZY or YY line, and then it's rotated about and brought up again perpendicular. So it's always perpendicular to our lines of intersection. Now, the one important point which I didn't mention on the last sketch, because I wanted to come back to it, is if you imagine this object in space, this distance here, so if we look down, we're again seeing this as the edge view of the wall. This distance stays the exact same as this distance, because if we imagine it in 3D again, where is my 3D sketch? Here. So this object is sitting in the middle of the room. It's sitting that distance away from this vertical plane. But if we look down, we will again see that distance here. So again, that distance is the same as that distance. And what that looks like is it looks like this. This distance here is the same distance as here. And this is what's shown. Now there's one other way we can project these up rather than using a compass. If you project these up at 45 degrees, it will make it the exact same as rotating it. So I just wanted to show that. So if we project these up, let's come out perpendicular to hit our YY line or our ZY line, and then come up at 45 degrees or down at 45 degrees, whichever way, you can then bring them up or down and you can find your end elevation again. Okay, so that is how first angle projection works. If you have any questions, let me know. Hopefully this was helpful. Thanks.